How can you use multiplication to find equivalent fractions?
Hi there. Denzel and I have been watching the customers at the gas station come and go all evening.
Let's compare the fractions in this problem. Let's unlock this problem. This problem compares thirds with sixths. Let's find the number of sixths that are in the fraction 2/3 so that Patty fills her measuring cup with the same amount of dish soap. There's 2/3 of a cup of dish soap in the homemade bubble solution. Each section of the cup shows 1/3. This shows 1/3 of the cup. This shows 2/1/3, or 2/3 of the cup. This shows 3/1/3, or 3/3 of the cup. 3/3 of the cup is the same as 1 cup. The amounts are equivalent. Patty's measuring cup is divided into sixths. Sixths are 6 equal parts of one whole. This shows 6/6 of the cup. 6/6 of a cup is the same as 1 cup. Let's compare sixths to thirds. How many 1/6 sections in Patty's cup are equivalent to 1/3 of a cup? 1/3 of a cup is the same amount as 2/6 of a cup. There are two 1/6 in 1/3. Now, find the number of 1/6 sections that are equivalent to 2/3, since Patty needs to use 2/3 of a cup of dish soap to make the bubble solution. We know that 1/3 is equivalent to 2/6. We can use what we know about equivalence to find the number of sixths in 2/3. Since 1/3 is equivalent to 2/6, another third will have 2 more sixths. That's 2 times as many sixths as is in 1/3. You can find the number of sixths that are in 2/3 by skip counting by 2's for every 1/3. 2 more sixths is 4 sixths, so 4 sixths is equivalent to 2/3. Patty needs to use 4/6 of a cup of dish soap in her measuring cup to make the homemade bubble solution.
Remember, if they are equivalent, which means they are the same. If you look at the picture here, 1/3 and 2/3 has the same amount of liquid, or homemade bubble solution in this case, as 4/6. Okay?
The circle is shaded to show 1 part out of 4, or 1/4. Divide the circle into a greater number of equal parts to show equivalent fractions. This circle is divided into 4 equal sections, or fourths. One section is shaded. It represents 1/4 of the circle. Divide the circle into eighths so that there are 2 times as many sections in the shaded area. When the circle is divided into eighths, the area in the circle stays the same, but has 2 times as many sections. Since there are 2 times the number of sections in both the circle and the shaded part, you can multiply both by 2 to name the fraction. The new fraction, 2/8, is equivalent to 1/4 because the size of the shaded area hasn't changed. Now divide the circle into 12ths.
So those pieces are going to get smaller yet, so I'm adding more equal pieces.
When the circle is divided into 12ths, the area in the circle stays the same, but has 3 times as many sections. Since there are 3 times the number of sections in both the circle and the shaded part, you can multiply both by 3 to name the fraction. When the numerator and the denominator of the fraction are both multiplied by 3, the new fraction 3/12 is also equivalent to 1/4. Divide the circle into 16ths. When the circle is divided into 16ths, the area in the circle stays the same but has 4 times as many sections. Since there are 4 times the number of sections in both the circle and the shaded part, you can multiply both by 4 to name the fraction. When the numerator and the denominator of the fraction are both multiplied by 4, the new fraction 4/16 is also equivalent to 1/4. Since 4/16 is equivalent to 1/4, what other fractions is it equivalent to? It's also equivalent to 3/12. 3/12 is also equivalent to 2/8. And 2/8 is equivalent to 1/4. So, 4/16 is equal to 3/12, 2/8, and 1/4.
So they're all equivalent. 4/16, 3/12, 2/8, and 1/4, which means each one of those, even though the numbers are different, they represent the same amount of that pie.
Name an equivalent fraction for 2/5. A rectangle is divided into 5 equal parts. There are 2 parts shaded. What fraction does this model represent?
What fraction does it represent? 1/5, 2/5.
Nice work! The model represents 2/5. 2 of 5 equal sections are shaded.
And we've done this before.
To find an equivalent fraction, divide the rectangle into a different number of equal parts. Divide the rectangle so the sections are tenths.
So we have 5 equal pieces. We're just splitting them, making 10. So each one of these pieces, we're going to split in half.
Since the rectangle and its equal parts have been divided in 2, it now has twice the number of sections. How many equal sections does the rectangle have now?
Let's count them. Ready? How many equal total sections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, let's check.
Good job! The rectangle now has 10 equal sections. There are also twice as many sections that are shaded. How many sections are shaded in the rectangle now?
So remember, they didn't change the pieces that are shaded. They just split those pieces in half. How many pieces are shaded? 1, 2, 3, 4. So I have 4 pieces that are shaded and 10 altogether.
That's right. There are 4 sections that are shaded in the rectangle. You can multiply the numerator and the denominator by the same factor to find the fraction that's represented by the model. What's that number?
Two times. We're multiplying it by 2 because we're just doubling it.
Nice work. You can multiply the numerator and the denominator by 2.
Okay, so
To find a fraction that's equivalent to 2/5, solve the equation using multiplication.
all right, so we're going to pause right here, Maria, And what I want us to focus on today, this is a great introduction. Instead of getting the multiplication part of it to find equivalent fractions, let's just work on naming equivalent fractions, all right? So go ahead and close this video off and we're gonna do some practice with just naming equivalent fractions.